Hi everyone, welcome to another practice problem walkthrough by physacademy.com. In this video, you'll work on a practice problem that focuses on converting a vector's length and direction to coordinates and subtraction. Let's read the problem statement and analyze it together. Deserted on a deserted island, you spot a slightly exposed tin can under a tree. Upon opening it, you find it is instructions to a treasure, and it reads: Step 1. 10 paces from this very tree, in a direction 20 degrees south of west, lies the first location. Step 2. 10 paces from this very tree, in a direction 60 degrees north of east, lies the second location. Step 3. Walk from this tree exactly the distance and direction you would walk from the first location to the second location, and you will find a treasure. Yar. Find the coordinates of the treasure. Let's start by marking our current location or position in physics. Then, we set the origin of our coordinate system right at our current location. I have east, north, west, and south already marked. Let's work through step 1. This vector indicates the location of the spot 10 paces from the origin of the coordinate system, in a direction 20 degrees south of west. This second vector indicates the location of the spot 10 paces from the origin of the coordinate system, in a direction 60 degrees north of east. Delta R1 to 2, or in short, delta R1 2, goes from the first spot to the second one. The mathematical representation of delta R1 to 2 is exactly the same as what substituting R2 from R1 would be. Let's write it down in a mathematical format. Delta R1 2 means delta R from 1 to 2. R2 is pointed to the final position. R1 is pointed to the initial position. So, if we find the coordinates of R1 and 2, we can come back to this equation and find the coordinates of the treasure. Alright, now that we have a roadmap, let's focus on the first spot in finding its coordinates. We use the right triangle analogy to convert a vector length and direction to the x and y coordinates format. The right triangle that matches this vector is shown in the picture. Let's separate this triangle from the picture for the sake of simplifying it and analyze it by itself alone. The length of the x component is the same as the length of the adjacent of this triangle. The adjacent length is hypotenuse times the cosine of the angle. The same for the y component, the length of the y component is the same as the length of the opposite of the triangle, which is hypotenuse times the sine of the angle. Now that we have the length of the x and y components, we go back to the coordinate system to pick the right sign for them. In this case, both x and y components are on the negative side of the axis, so our one coordinate is negative 9.397 for the x component and negative 3.420 for the y component, and the unit is paces. For R2, the process is the same. We find the right triangle that matches the vector, then we match the hypotenuse, adjacent, and opposite with the x and y components. After a bit of calculation, we get 5 and 8.660 paces. To find the sign of the components of the coordinates, we check the coordinate system. In this case, both x and y components are positive, therefore we get 5 and 8.660 paces. Alright, now that we have the coordinates of R1 and 2, we can go back to the original equation. When subtracting two vectors, we need to subtract the x components together, separate from the y component. The same is true for the y components, we shouldn't mix them with the x components. Anyhow, after a bit of calculation, we get 14.397 paces for the x component and 12.080 paces for the y component. Then, we move the beginning of the resulting vector to the origin of the coordinate system, and its end is pointed to the treasure's location. Thank you very much for watching this video. Please check our website, physacademy.com, or our YouTube channel for more practice problems. If you found it helpful, please consider subscribing to our YouTube channel to support our work.